they don't use, if it is a bare metal virtual machine, you can guarantee, there are two types of VMs, right? There's something called bare metal, like a Hyper-V and all. There you can get good performance, or VMware. If it is not a bare metal, no, performance will be compromised, because again you have to go through one layer, then talk to the storage and all. So I'm just taking this ICICI use case so you guys will understand better. So traditionally we do something called ETL to bring the data, right? And now what we have this Hadoop. So I'm just writing here HDFS. So this is your HDFS file system. This is HDFS. And in the world of Hadoop, we very rarely do ETL. Why? Because ETL means you are reading the data, transforming the data, and dumping the data. If you are getting big data, transforming it on the fly is very, very difficult actually. So in the world of Hadoop, what we do is something called ELT. Instead of ETL, you will do something called ELT. That is extract, load, and transform. So first thing is extraction. How do you get the data into a Hadoop system? So there are multiple tools. First of all, if you are having structured data, say you have data in Oracle, you have data in MySQL. So this is all structured data which understands SQL. There is a tool called Scoop. There is a tool called Scoop. Scoop can get this data to your HDFS. You can't call it as an ETL tool. Scoop is used to bring the data from any SQL system to Hadoop, transfer the data. So what is going to happen when you say that you want Hadoop from Cloudera? Cloudera will give you Hadoop. On top of that, it will give you all these tools which I'll be explaining now. So Scoop is part of your Hadoop ecosystem. And Scoop is used to bring data from SQL stores. It can take from, let's say, Oracle. It can take from MySQL. But it cannot take from flat file, JSON, nothing. Only SQL, only places where SQL understood. So from ICICI use case, we got all the data from CRM through Scoop to Hadoop. Okay, so Scoop is an Apache tool. It is a very lightweight tool. We faced a problem there. I wanted to discuss that. Let me ask you this question. This is ICICI Bank's core banking Oracle database. Do you really think they will allow you to touch it? Then how do you get the data? CDC, change data capture. So we face the same problem. There is Golden Gate. Oracle has a solution called Golden Gate. So CDC, change data capture, meaning they will not allow you to touch it, right? So they will have some replica solution. So where they will write it into a replica DB, it's actually a log file. From there you have to capture and get it. They won't allow you to directly touch their Oracle DB by any way. It's called CDC, change data capture. No, that will have only the delta. So what they will do, they will give you the original data, backup data they have. The CDC will capture only the changes in the database. Got it? And then you have to, from CDC, you can write a Java code and then get the updates dumped into here. That is how you get it. So Golden Gate is a product that Oracle uses for CDC. Anyway, we use Scoop to get from here and here, right? Now comes the place where we are having a lot of debate, actually. Okay. Now the real question is that, okay, I know how to get the data from here through Scoop, right? What about the other data, right? Now, if you want to get the other type of data, there are multiple ways you can get, okay? One of the most popular used tool is called Flume. Apache Flume. Flume is a point-to-point delivery tool. What Flume does, it takes the data from source, give to the destination. The source can be anywhere. And normally Flume is used for unstructured data. Say for example, in a folder, you're getting all the JSON data or XML data or flat files. I can create something called a Flume agent, and this guy will keep on polling that folder. Whenever there is a new data, this guy will read it and it will send it to HDFS. This is what Flume does. Now, the real interesting thing is that Flume can do two things. One thing is that it can simply read all this data. Let's say this is in a folder. Okay, it can simply read this data and say send it to Hadoop. This is fine. But ICICI Bank also had another requirement. So this is simply you're collecting the data and dumping into Hadoop. They don't want to do that. Okay. So they wanted, they had a requirement in which what used to happen was that this Flume was capturing some data. Okay, some data was getting generated in the form of JSON here. So in the social media, if somebody is clicking on one of their products, they wanted to send an SMS, real time. So this JSON data will keep on coming. You will keep on getting it. And Flume can directly dump into HDFS. But that is useless for me because I want to analyze the data whenever the data is getting generated. That is where this guy comes into picture, Kafka. So there is a difference between Flume and Kafka. Okay, you have to understand. Flume is like a point-to-point delivery. You give me the data, I will dump it there. That is all Flume does. It doesn't do anything. And Flume does not store the data anywhere. Meaning it will take the data, temporarily it may store and then immediately push the data. So Kafka is your message queue in the big data world. Meaning what this guy will do, this guy will be running in its own cluster. No Hadoop cluster. This guy will run on its own cluster like 30 machine, 40 machine. This guy, Flume can send the data to this guy, Kafka. And Kafka is a cluster, so it can store the data. By default, it can store for 7 days. By default. Okay. Anybody can go to Kafka and get the data. Publish subscribe system, we call it. The advantage is it will store the data so that multiple people can ask it. Flume is point to point. If Flume gets the data, it dumps the data here. So here what we used to do, we didn't do this. Okay. We got the data to Kafka. From Kafka, I can push it to HDFS one way. So I'm getting the original copy here. Okay. Now in ICICI Bank, so the next question is that how do you analyze data in real time? So somebody is clicking on Facebook, the data is coming as XML, right? And immediately when the data comes, Flume will read it, push it to Kafka. So now the data has reached till Kafka, but I want to analyze the data in real time. That is where your Spark comes into picture. There is something called Spark streaming. In Spark, you will learn this, I think, I'm not sure. Okay. There is something called Spark streaming. So Spark streaming is a utility which analyzes real-time data. Now, Kafka can also directly get this data. Now, this is a bit confusing, I know, okay, because this is very new to you, first of all. But Kafka can also directly get the XML file. But the advantage is that Flume is pull-based. Pull-based means if I install Flume, without disturbing this setup, I can pull the data. Kafka cannot pull the data. You have to install a tool here and modify the existing setup. Flume is pull-based, meaning if you install Flume here, it can start reading the data automatically. I don't have to modify anything. If I install Kafka directly, Kafka can also get the XML data. It can read the XML data, but I need something called a Kafka producer. That has to be installed here on the ICICI source system. That is not possible, right? So since it is an existing setup, I can't directly get through Kafka. I get through Flume. Flume will give to Kafka. Kafka will send one copy to HDFS because I need to keep the original data. Second copy it will send to something called Spark streaming. Spark streaming is a library available in Spark where it can do real-time processing. The moment you give the data, it will process it real-time. Somebody clicked on that, immediately the data is here. Spark streaming will process it and say send an SMS or you can take an action, whatever you want. Now, what are the other tools which can do real-time? Apart from Spark streaming, you have something called Flink. You have something called Storm. These are all real-time processing tools. You might have to make a note of that. Yeah. So in WhatsApp, it is push, right? Flume is like WhatsApp. Okay. Once Flume gets the data, it will push it to somewhere. It will not store the data. Kafka means it will get the data and store it for you as long as you consume it. So in ICICI Bank, this was the architecture. We got it through Flume, sent it to Kafka. Here one copy will go to Spark streaming. So this guy will do real-time processing and do something. Okay. One copy will go to HDFS. So the data will remain in Kafka as long as you want. You can configure. By default, it is 7 days. You can also mention the size of the data. I want to keep only 10 GB data, 20 GB data. There is something called topics in Kafka where you can mention how long the data should stay here. It's a cluster, right? Flume can send here, then this will not happen. It is point-to-point delivery. I need a copy here. I need to send there also at the same time. Also, probably tomorrow, I want to build one more application, okay, which will do something on this data. And that application, I have a new application I built tomorrow that can also get the data from Kafka. Kafka is like, if you give data to Kafka, anybody can take it from you. I will store it for you. Got it? Flume is like point to point. Got it? Kafka will store it so that anybody can come and get the data. 10 applications can read from Kafka. It will be very slow, hardest to read. I can directly push in real time, right? So before you get out of Tanik's shop, I want to send an SMS, right? No, this will be one golden copy will go here. The original Facebook clicks and all golden copy will go here. That tomorrow you can analyze. Now you clicked on a page, insurance page in Facebook. I want to immediately contact you. So it has to be processed and understood, and then some decision has to be taken. So I'm sending one copy here, one copy here. Here the processing will happen. Here simply the original data will be stored. No. Flume and Kafka cannot. Only Sqoop can read from SQL-based stores. Now Kafka is a very interesting thing. I teach a 3-day course only for Kafka. ELK stack, right? No, ELK stack will not come here in this example. We didn't directly use ELK stack. We were using, that's what I was telling in the break to somebody. What we were doing is that we used to store the data in Hadoop. To process, we were using something called Splunk. There is a tool called Splunk. Splunk can actually replace your ELK stack. It does ELK both in one tool. So that is for visualization, right? You have some log files, machine learning. You can just apply and visualize. We were using something called Splunk. So this is the big pipeline I'm talking about. You can also build it using ELK if you want. I'm just saying. ELK is a stack actually. Elasticsearch, Logstash, Kibana. It's a probably he can explain, right? So let's say you're getting a lot of log files. You want to make sense out of it, right? From different places. Let's say I'm collecting all the logs from this network. I want to make sense out of it. So I need a tool which can easily collect it, clean it, and then display in a dashboard. That is ELK, what it is doing. There is a tool which is very similar. That's called Splunk. That is not in the in the Hadoop ecosystem. It is not there. That is a third-party tool actually. Exactly. So that's a good question. So when Sqoop is getting the data, right, Sqoop will ideally push only to here, HDFS. Okay. But I can say Sqoop to push to Kafka also. That is also possible. Once the data is available in Sqoop, okay, I can say give it to Kafka. So either it can be read for live processing, or Sqoop can push to something called Hive. We have a Hive here, which is a data warehouse. From there, I can analyze in live if I want. But normally, this transactional data is not much used for real-time processing. You are doing it based on this Facebook clicks and all. Based on this transaction, I can get it. Now, just to answer his question, that's a good question actually. So can you give me a suggestion? So a customer is making a transaction. A customer is making a transaction using ICICI credit card. He made a transaction for 50,000. I have to immediately send him an offer. So if he's making a transaction here, I made a mistake here. I want to show that. If he made a transaction here, 50,000, okay, where will be the data? In Oracle. How do you capture the data from here? You will say Sqoop. We were using Flume because your CDC will be producing a log file. The log will be captured by Flume, not Sqoop. So here Sqoop will not come into picture. Here Sqoop will come because I'm directly reading from CRM. My CRM is in MySQL. MySQL is original table and I can read directly. But in the Oracle case, I was not directly reading the table. If I want to read a table, Sqoop. But we were reading the CDC, change data capture. That was a log file. That was being collected by Flume actually. So you can actually make it. So this is the answer. If you want to make real time, okay, you need some CDC system which can push the data to Flume. I have worked on a banking use case where, so I'm talking about this side, Spark Streaming, Flink, Storm. So Spark Streaming is what you will be learning. Flink and Storm are other frameworks which can do real-time data processing. So you will be wondering why real-time data processing is so critical. All three are real-time. You may use any of them. Flink is Apache, Storm is also Apache. Storm is almost out of the market. Okay, Spark Streaming and Flink are popular right now. We have worked on a use case with Citibank. You swipe your credit card, right? How do you know it's a fraud or not? You are swiping your credit card. I want to find out whether it is a fraud transaction or a real transaction. You don't have to be a fraud. Let's say I use a credit card regularly. If I one fine day, if I suddenly pay in US dollars or something, I'll get a call from customer care. Did you really make it? That means, imagine, say HDFC Bank, how many credit cards will be in circulation and how many people will be transacting every day? Do you think somebody is sitting and monitoring every swipe? You are collecting all the data, all the credit card transactions will get dumped, okay? They won't come in a relational form. They will come in some flat file or something. Your Flume will catch it. The moment it comes, it will push it through Kafka or directly to Spark Streaming or Flink or Storm. And there I could have written a logic, okay, match this transaction if this guy's limit is something or his last transaction made places outside India or something, trigger a mail to customer care. That is how you are getting this EMI calls also. When you make a big transaction, immediately they will call and say, do you want to convert to EMI, right? These guys are responsible for that. What is the difference? This Storm can process one event also. Meaning one credit card transaction Storm can process. Ideally, one credit card transaction it will process, minute. Spark Streaming can process only bunch. It cannot process one. Meaning, it will collect probably 2 seconds worth all the transaction and predict. So that's called micro batching. It is creating a batch and then from that it is processing. 100% real time is only possible with Storm. And Flink also does the same, I think. This securities we were not handling. I'm not 100% sure how it is working. Our use case was only limited to this, right? But now I have a question. Okay, the question is very much valid. You are making a credit card transaction and Spark Streaming catches it. Spark Streaming catches it, but that is the real-time transaction. How does it know that this is a fraud based on the previous transaction? So if I am making a credit card transaction today, all my previous transactions are already here. They could have already built a machine learning model. And if you simply feed this new transaction, it can predict. Otherwise, how do you compare with batch data? I cannot run a batch job. It will take a lot of time, right? All the customer data. So they will run a MLlib. It's called MLlib in Spark. Machine learning model will be running. That will easily compare and say it's a fraud. If you want to compare the batch, see, now I'm just making a transaction, right? It has to compare with my previous transactions to understand whether I'm a fraud for the last 10 years. Today I'm swiping in New York. New York swipe, if you want to understand this an anomaly, you should compare it with previous swipe, right? Now, each time you cannot go and compare for each customer. So they build a machine learning model based on all this data that can, if you feed a data, it can predict, whether he will be a fraud or not. It will not directly compare and get. This I'm talking only about fraud detection. So your use case is your this thing, right? Stock market price variation. So my point is this historical data will be huge. It will be in terabytes, right? So you could have already created a machine learning model by feeding this data, which if you give any new data can predict whether it is fraud or not. That is happening in real time. I cannot say that once if somebody swipes a credit card, I will tell you whether it is fraud tomorrow. Doesn't make any sense, right? I have to do it immediately. Now, the flip side is that all this requires resources. Nothing is going to work if you don't have resources. So you need to give enough resources for all these things to work. Machine learning and all are very resource hungry. CPU power, RAM power, right? So these clusters should be capable of doing this. Anyway, for the time being, let's move on from Kafka, right? So we are just taking a use case, right? Now, I'll go here. Once your data is in HDFS, if you want to do batch processing, the default framework is MapReduce, MR. But I have my data, I want to do batch processing. I don't care how much time it takes, 1 day can take. I just want to process the data, I can use something called MapReduce, right? You also have one more guy called Pig. This is almost gone from the market. Pig, the animal pig. Pig is a scripting tool on Hadoop, but not very popular now because of Spark. So nobody is actually, so even if you are not aware of Pig, it is perfectly fine, I think. Okay, you don't have to worry. And then you have somebody called Hive. This is there in your syllabus. So Hive I will teach in the next month, but basically what Hive allows you to do is to write SQL on top of Hadoop. But the drawback is you say create table and select count star from the table, hit the query. It will convert your query into a MapReduce program. So it's a translator. It is not a native SQL engine. Instead of learning Java, right, we'll stick with SQL, ETL jobs we will run. They created this tool called Hive. So if I'm a Hive developer, I don't have to learn anything. It's SQL. I say create table, join. But once I say join, it'll write a MapReduce for me. Then the MapReduce will run. I may have to wait for, in fact, in Flipkart, there was a Hive query which took around 12 hours to run. Then they fine-tuned it and all, but that's a different story. But These are all batch processing systems built on top of Hadoop, right? And then you have Spark. You will learn Spark later. I don't want to confuse you a lot. So Spark is there. And this guy is inside Spark, okay? Even though I wrote it here, this guy is inside Spark. Spark is an in-memory execution engine. Spark is again classified as a batch processing system, but very, very fast than MapReduce. The only difference is that Spark programs are faster than MapReduce programs. Near real time, not real time. So Spark streaming is actually real time, but I would say near real time, not like 100% real time. MR and PIG are obsolete. Hive is not obsolete because Hive is your data warehouse where you create tables and store the data. So this guy will remain, but now what is going to happen? Spark will connect with Hive. And Spark can write, yeah, so here you can write a SQL, okay? Spark has a Spark SQL library. It can read tables from Hive and run on top of that, right? So Spark will start talking to Hive. So Hive is not really obsolete. Hive, so if I want to run, okay, again there is a confusion. If I want to run a very big group by query, let's say I want to read the full table, scan and run a query, Hive is great. Even Spark SQL with Hive is great because they will read the whole data and process it. But if I have minute queries, let's say select something from the table where name equal to Raghuraman. Only one row it needs to process. For that, why should I load the full data and process? It is useless. But Hadoop says load everything sequentially and then process. That is only possible. That is where you have this MPP engines. Impala. There is one guy called Impala. There is another guy called Hawk. Hawk and LLAP. There is something called Presto. Presto. There is also something called, what is that? Drill. Phoenix. These are all MPP engines. What Impala does is very simple. It has its own execution engine. You fire a SQL query, it will run it for you, no MapReduce. Right? So what is going to happen for these queries like where name equal to Raghuraman, you can fire an Impala query. It will scan only that data. Right? So it can connect with HDFS and pick only the data because it remembers the metadata. Where is what data available? It can columnar, it can pick that data and query. But then you will be wondering, why can't we use this instead of Hive? And these guys are very fast. So if these guys are too fast, then why don't I use them instead of Hive? They don't have reliability. They are all in-memory queries. If an Impala query is running in my Hadoop cluster, if any one of the machine crashes, my query will be gone. If a Hive query is running, even 10 machine crash, query will complete. It is MapReduce. Built-in redundancy is there. MapReduce will never fail, or Spark will never fail. But if I'm using Impala, okay, it has its own metadata. It knows where is the data. It loads only that, and queries will be faster. So if I run an Impala query, considering a Hive query, Impala queries are much, much faster, but no fault tolerance. So for these very fast queries, like your queries can take like 2 minutes, 3 minutes time, you can afford to lose a query, use Impala. But if I'm having a ETL job where I don't want the job to fail, run it using Hive or Spark SQL, because these guys will never fail. So all MPP engines are like this, I think, in the traditional world also. In this, the difference is Impala is on Cloudera. Hawk and LLAP are Hortonworks. So there is a competition. Impala was originally created by Cloudera, so they promote it. If you are in a Cloudera platform, you will see Impala. If you are on a Hortonworks platform, you will never see Impala. They will promote Hawk. They will say Hawk is the best engine. Okay? And LLAP is the new version of Hawk. Presto, Drill and all are similar ones, but not by default available. This guy is very, very interesting. So there is something called HBase. I will add it here. Somebody was asking me what is HBase. HBase is your database of Hadoop. NoSQL database. Real-time database. Real-time. Because HBase will get installed on HDFS. There is your storage, right? But it can do random reads and writes, not like entire block. So normally when you are reading the data from HDFS, you have to read the whole block, right? But HBase has an API. So if you install HBase on top of Hadoop, it can do random reads and writes. Individual records it can read and write and process, because it is a NoSQL database of Hadoop. the default NoSQL database. But the drawback is HBase has its own language. So if somebody has to work with HBase, you have to learn the language. It will not allow SQL queries. Phoenix is SQL on HBase. Phoenix and HBase is like roti and paneer butter masala, deadly combination. I mean, very deadly combination because you are writing SQL on top of NoSQL, right? Very deadly. So they say that in another 2 years, it will not be slow. It's really fast because HBase itself is fast. SQL, there is a conversion, okay, but that's already built in. Any SQL query, there are some limitations, but so Phoenix will get all the metadata and already all the queries are converted. Whatever query SQL you are writing, it knows what is equivalent HBase query. So it has just push the query. So you just write a SQL, it will run on HBase and give you the result. And it can do things like secondary indexes and all. It can index your data apart from HBase. It's very fast actually. Now the real news is that in another 2 years, what is predicted is that this combination, the drawback is Phoenix is still in alpha beta. Phoenix is not production ready. Once Phoenix becomes production ready, this is OLTP. So they are trying to make it ACID support so that this entire combination will become an OLTP system like that, right? So then what will happen? You will get transaction management in Hadoop. So far it is not there. Another 2 years down the line, they say that, so Phoenix is getting integrated with HBase. Originally HBase was only there. The drawback is it doesn't understand SQL. So Phoenix started, Phoenix is a layer on top of that. You can write SQL. So in another 2 years, they are developing this as a system for transactional management. So you'll get true transactional management in Hadoop. So if you talk about the Cloudera and all, if I'm going to Cloudera and say that I want your product, they will give you all this in one package. But if you go to Apache and download, you get only HDFS, MapReduce and Yarn, only Hadoop. All this you have to separately install. So commercial distributions will package it and you will not get everything, okay? For example, Hawk will not be there. This Presto, Drill, Phoenix, you will get HBase, Hive, Pig, MapReduce, Spark, Impala. So these things you will get. Look at here, Spark, Hive, Pig, MapReduce, Spark, Impala, Yarn, right? But you have HDFS, HBase, Kafka, Flume, Scoop. This is a real product from Cloudera. You go to Cloudera, this is what you get. Some of them I have not even explained because I don't know. Kite, I don't know what it is, to be very honest. Kudu is a new file system, relational. Even I'm not aware of Kudu. I don't know what it is. But these are like new entries. Even if you don't know them, you will work without any problem. And for security, you have something called Sentry. So a lot of people are worried about security on Hadoop, right? So there is a service called Sentry, which will handle like access management, authorization, authentication, or this will be handled by Sentry.